This is Dr. K. Rajendra Prasad. I am working as professor and head of the CSC Cybersecurity Department. Today my topic is continuation of from regular expression to finite automata. We see that in the last case, regular expression. What do you mean of regular expression is we have gathered so many concepts and also so many examples relevant to the conversion from regular expression to finite automata. But in the finite automata, we have basically two types: non-deterministic finite automata and also deterministic finite automata. We have required to convert the given regular expression to NFA. One more conversion is the given regular expression to NFA and also to DFA. So that is about today's topic is the previous class continuation. We see in more detail. The topic idea is regular expression to finite automata. Here we assume regular expression are better choice because of for the compiler construction, lexical analyzer is one of the primary phase. So this lexical analyzer will do performing of scanning process or also called as a parsing process. What do you mean of scanning and parsing is? It scans each character at a time. Like that, it will process till the end of the character in a particular token. So that idea is given by regular expression. So regular expression nothing but it also have the some set of value strings which are generated by the finite automata. So those value strings all are accepted by the finite automata. So the corresponding set is called as a regular set. The corresponding language is called as a regular language. Therefore, regular expressions are the choice for describing the lexical analyzer. Because of the lexical analyzer, we have seen many cases for generation of the tokens, that is valid tokens and also called as valid lexemes. So we have to see in today's class is non-deterministic finite automata, how you construct non-deterministic finite automata for the regular expression. Because of once we know the language and we have to know that syntactically or meaningfully we have to generating some strings of the language. All these strings are accepted by the finite automata. And one more assumption is all these valid strings of the particular language that can be easily identified by or accepted by the non-deterministic finite automata. Here we have to see the cases non-deterministic finite automata can be easily constructed for the regular expression is one of the reasons for choosing of NFA and finite automata. And one more thing is the expressions are described for the accepted language of the finite automata. What do you mean is this is a language you are taking, one particular language you are taking, like A, 2As, 3As. Means for this acceptance of all these languages, all these language strings that can be defined by one particular finite automata that's called as FA, for the some strings, therefore the some strings. It may be added with repetition of A's. This case, you may assume null A, 2As like this, but prior to that you can add one more symbol A and A star becomes A plus. Means, so for this regular expression, we have the value strings that can be defined by the language called as regular language. It's called as regular language. And one more thing is these language strings or language patterns all are accepted by the finite automata. Therefore, there is some equivalent relation. So every regular language that can also accepted by the finite automata. Means language strings that can be accepted by the finite automata is possible. Then you can also describe the one regular expression for denoting the set of strings of the particular language. That is the idea of regular expression. The final assumption is regular expression that can be used to describe whatever strings are accepted by the finite automata. All those strings that can simply expressed by a simple pattern. That pattern is called as regular expression. Here, some cases I'm not giving a language, I'm giving a regular expression only. In that case, how can you convert the regular expression to finite automata? That's we have to observe. So, as per the definitions, what is regular expression? Straight away, regular expression is a pattern that describes set of strings that matches pattern, and the corresponding set is called as a regular set. Means here the language strings previously have to see a, 2s, and 3s like this. Is also called as a regular set. Is also called as a regular set. Is called as a regular language. Is called as a regular language. And one more thing is the expression. So regular language strings, that is elements of the regular set that can be defined by, instead of showing the all elements of the regular set, we can go for defining one simple expression. That expression itself describes the elements of the language or elements of the regular set. That expression is called as a regular expression. So you see that what do you mean of regular expression? It is a simple expression that describes the elements of regular set. The elements of regular set that can describe what valid language is called as a regular language. You want to accept the language strings, you need to construct the finite automata. Today, that is we have described to NFA. By NFA, you can accept the regular language. The meaning is you can accept each and every string of the regular language. There is a valid string of the regular language, or indirectly we can construct the NFA for the corresponding regular expression. The corresponding regular expression. So you have to see the two cases, NFA that accepts the strings of the regular language, or you can construct the NFA for given regular expression. The meanings are same. So today topic is I give a regular expression to finite automata, or we are assuming the meaning is I'm providing some set of strings or set of elements for the regular set. For that we can construct the equivalent in FA. That is we have discussed in today class. We see that these are the standard notations we have to follow in the case of regular expression to finite automata construction. Here I am giving you some standard notations. The first notation is A denotes the set. Here A is a single element. The regular set is called as A. Within the cloud brackets, I define regular set is A. Suppose here it is called as I am assuming element, or also called as regular expression. It is called as RA. The meaning is regular expression. So the corresponding regular set is a set, or language strings is also called as a language string. So this set is called as a regular set. Regular set. So similarly, we have take the another formal case is also very important, because we are getting a regular expression case. Most frequently, you are getting all these totally for 5 different formats. Any single element, or any 2 elements, or more than 2 elements are there. You can apply either union operation or concatenate operation. Here, union operation that can be described by the plus operator. Here, the plus nothing but not adding the two numbers. It is not equal to the meaning of addition operation. The plus nothing but union is called as a union operation. Means we go for one element set is like this, plus another element is b nothing but here you applying the meaning is union. So finally you have to get in the elements are a comma b. So place it gives the total for two meanings. One is called as R operator and also union operator. Union operator. So we have to getting so many meanings for plus. Means I am taking more than two elements. We can apply plus nothing but between the two elements. The meaning is you making union between the corresponding regular sets. So what is the corresponding? Suppose I am taking here a plus b. A plus b. What the corresponding set is? A corresponding set is A. B regular expression corresponding set is B. Between that you applying is a union. So plus denotes you make or you can apply union between the two elements or two regular sets, A regular set and also B regular set. So finally we got what the result is A comma B. That's the how to obtain here. The second formula. Third formula also we are using more frequently in the regular expression concept. Means here I am taking any two regular expression. A is one regular expression, B is another regular expression. I want to make the concatenation between these two regular expressions, then the symbols are merged. Finally, I form the string is AB. That is how to happen. Concatenation, nothing but matching the symbols of A and B. Plus nothing but making union operation between the A and B. And one more thing is the star. Star nothing but is also called as the closure. Regular expression is A star. Is also called as the closure of A. As per the previous discussion class, what indicates the star nothing but it allows null symbol or single occurrence of A, two times the occurrence of A, three times occurrence of A, like that and so on. This is called as the A star. This expression or this form also we can use very frequently in the regular expression. Finally is A plus B whole star. Here determine the meaning of A plus B whole star is very important because of the A plus B whole star is understanding. Once you understand this one, I think it is very easy. Means simply you are assuming in the real world you can getting any string with the combination of A and B, the combination of A and B that is covered in the case of A plus B whole star. Suppose, for example, you have to see the case is A plus B whole star. What the derivation is as per the formula is it is which is equal to A star concatenate with B star and also for whole star. So what the A star is, you know the values, null value, single A, two A's, like that, so on so. What the B star is, maybe for null value, B value, two B's, right, so on so. You make a concatenation of these two symbols again post star. You will see that null is concatenating to these symbols. You are getting a null, B, two B's and three B's like this. After that, A is there. A is concatenated with the remaining other symbols. A with the null is A because of symbol X is null with X is concatenated with null nothing but you get the same X as a formula following. So A is concatenated with A null symbol A. A is concatenated with B. A B. A is concatenated with two B's. A B B. Like that. We have to check it. What are the types of strings? We are getting many types. Means in the real world, with the combination of A and B, with the combination of A and B, any string. Suppose I want two A's, three B's. Definitely is there in the set. So simply, so we have to say that any pattern that should start with A, that should start with B, or only having the A's, or only having the B's. Any combination that covered the symbols of A and B, it is called as A plus B whole star. That is the final regular expression with also very important understanding of A plus B whole star. So A plus B whole star denotes all types of the strings. The strings having the combination of A's and B's. The combination of A's and B's nothing but it may be for any string. Sometimes to start with the A, sometimes to start with the B, or only A's, only B's also. That is called as A plus B whole star. So this is the idea of all these 5 basic regular expression formulas. With the help of these ideas, you may or you are going to solve any kind of regular expression. For example, here I am taking 101. 101 is the regular set. In the set only single element you are assuming, that is a 101. Means the meaning is this is the formula is like this. What the regular expression is A only. A is 101. So what the regular expression is 101. This 101 I think not for the separation of ones and zeros. 101 entirely is in the A. So finally regular expression is A only. So this we are assuming the first example in the table 101. I am taking only single element. You consider single element in the regular set. The corresponding regular expression is 101 only. Next case is null and also small a. Here I am taking the comma. Comma nothing but what the regular expression is definitely with the plus operator. Null plus a. Suppose for example I am taking a comma b comma c. What the corresponding regular expression is comma nothing but you are assuming here union is applied. Union operation that can be described by the plus operator. So a plus b plus c. This idea. So this is I think idea of the second example. Second example illustrating that the comma it indicates plus union operator. And one more thing is you see the third example is generally how to see the cases null is included, some symbols A is started, some symbols B are started, means some all types of combinations of strings. Those strings have the A's and B's combination or B's and A's combination, and also sometimes include the null value that can be defined by the A plus B whole star. Means in the real world, any string that can be formed with the combination of A's symbols and B's symbols, any pattern that covered under the A plus B whole star. We have seen another case, last case is AB plus BA. We have to check it total for how many number of elements are there. In the case of AB plus BA is here AB, one more is BA. We have to take total for 2 elements. This is the first element, this is for the second element. So that AB plus BA is for the final idea. So the corresponding regular expression is AB plus BA. I want to extend another example is ABC, BCD, DAC. Suppose I am taking like this. Simply common nothing but the meaning is you are applying here the operator is union operator. With this you are assuming ABC common nothing but union defined by the plus operator and BCD plus DAC. So this you are taking the case for understanding of what is the regular set, what about the equivalent to regular expression. So here in the case of regular expression and also for formulas of regular expression, we must remember total for how many formulas of but 6 formulas. Earlier in the previous slide described the same statements. Okay, and formulas point of view, we must know applying the total for 6 formulas, that is 6 different rules you are applying. First is regarding to single element or no element, or sometimes null element. Null element, the equivalent expression is null value only. No element, the regular expression is equal to regular expression is 5 value only. Single element, the regular expression is 0. This is indication of the first statement. The second is as usual R1 and R2. These two are two different regular expressions. You are applying the union operator. You are applying the union operator. So union remember, you must remember that how can represent the regular expression is between the R1 and R2 is R1 plus R2. You know very well from the previous slide. And the third one is concatenation. The operation name is called as concatenation. The concatenation of two regular expressions R1 and R2 written as the form of R1 and R2. Sometimes the concatenation operator that can be defined by dot symbol, dot operator. So dot. We also can write R1 dot R2. This is also concatenation. Or simply can write you must hidden the dot operator. So finally we are concluding R1 and R2 only. This is called as concatenation. Or you may represent the dot, you may not represent the dot also. And iteration, like in the for loop also, what happens? For loop not repeated, even single time also, null 0 number of times repeated. Or for I equal to 1 to n, suppose I am giving. So how many times the for loop is repeated? 1 time, 2 times, like n number of times. Here also we assume the same idea, that's called as a closure. Closure it also indicate okay what the operation is iteration. Okay, as per our programming language understanding, closure which is also used for the purpose of iterative statements, generation of iteration statements. See, iteration or closure, the meanings are same. Suppose is a null value, single time R is repeated, 2 times R is repeated, many times. Okay, that can be defined as a R star. That can be defined as a R star. And one more is, I think we have to know that in the arithmetic expression, left and the right parenthesis, balanced parenthesis. We want to define the way of applying the arithmetic operation, where we have to apply the first time and where is the second sub-expression, the third sub-expression you want to go for evaluating. So you must define the left and right parenthesis. Then there is no ambiguity for evaluating the arithmetic expressions. For that purpose, you make use of the fifth rule is this is the fifth rule. R is the regular expression, and we must also define the left parenthesis capital R, right parenthesis is also a regular expression. And you want to go for repetitively based upon our application. Okay, you may use the rules from 1 to 5 very frequently. There also comes under the rule 6 is rule 6 that can be defined. The regular expressions over sigma are precisely those obtained recursively by the application of the rules 1 to 5 once or several times. So this is the idea for the basic recursive definition of a regular expression over sigma. It can be defined with regard to 6 rules. So as per the rules, we have to go for is the first rule. I think already we have discussed it. Only for no value, empty or null value, single element, you have a single element. We can apply the rule 1 and 2. A plus B is the regular expression. We apply is rule 2. Union operation you are applying. This is the concatenation operation. So rule 3 you are applying. The star is the closure of A. Is also regular expression is the rule 4. And this called as left and right parenthesis of the expression. A expression is called as also regular expression. We are applying is the rule 5. Last one you have to see that AB plus A star and B star. What are the different regular expressions we are applying? In this case, we are applying all the rule is rule 3. Okay, the rule 3. And in this case, we are applying this case is rule 2. Okay, and star is means iteration statement. This is rule 4. Call as rule 4. and here A star dot B star is there, no? And here concatenation rule 3, and again B star is a rule 4. So it means iteratively we can make use of the statement between the 1 to 5 formulas that can be determined as called as rule 6. Means depends upon our problem, we make use of any one of the rules are defined between the 1 to 5. 1 to 5. You see that what the 1 to 5? These are the 1 to 5. 1 to 5. These are used very frequently in regular special. In the case is 8th case. That comes the rule 6. This is a better understanding of regular special. Once we understanding, then we have some variety of problems also there for regular expression. So these are the variety of problems we have discussed. Find the regular expression on the following. A language consists of the all words or strings. All words or strings nothing but you may apply this case is so what are the symbols? A and B symbols, no? So A plus B poster. A plus B poster, it indicates that the language has the consists of all types of strings and all types of words. And ending in B, you must ending in B. This answer. So the second one you have to check it. The thing is, a language consists of all the words over 0, 1. Here we have to take symbol 0, 1. So that's why 0, 1, 0 plus 1, 4 star. Ending in 0. This is the answer. And we are verifying the third problem is here also same thing. The first statement is same. All the words of over A, B. It indicates A plus B whole star. Starting with A, you see that starting with A means here starting with A, and ending in B is ending in B. So you can read as A into A plus B whole star with B. One more thing is a language consists of all strings over A and B. Is called as also defined as A plus B whole star. Having BB as a substring. Having BB as a substring. So it is something substring, assuming, right? And one more is a language consists of all the words over A, B ending in ABB. That can be defined as A plus B. Post of is nothing but all the words strings over A, B that can be defined by A plus B whole star and ending in A, B. So like that you solve all these questions very easily. Means here what I'm giving is a language is given, language to regular expression. After that you know the corresponding finite automata. We know the regular expression. What are the corresponding finite automata? This is a pi. Means here you are not reached from Q0 to QM. Nothing will be accepted. No element will be accepted. So no element that can be defined by the pi. The equivalent automata is the equivalent automata. Here we see that null. So means here starting and ending the same state that can be accepted with the null symbol only. Here we are checking the A. How can define the A nothing but we take an initial state is Q0 and ending with the QF with the symbol is A. The symbol is A. So A is accepted. So press nothing but the meaning is already told union or the meaning is or operator. Or nothing but you go for A or you go for B. So similar pattern you have to get. This called as A plus B. Press nothing but or operator or union operator. And the concatenation that can be defined by the dot symbol. The symbol A that must be concatenated with the symbol is B. It's called as AB. And star nothing but repeated occurrence of A, including the null symbol also. That can be defined by the A. I want to go for suppose A star and also B star. That can be idea is like this. Human is also A, also for B. Like many symbols expressions are there like A star, B star. We must define the two self-loops A and B. Or sometimes you want to go for like this also A, B. Means this is also called as A star, B star, O star. And similarly, the corresponding places means except null symbol. Here null symbol is not there, no, here what the corresponding finite automata is. So these are, I think, basic ideas you must know that before proceeding the problems of regular expression to NFA and NFA to DFA. So we'll see that ideas in coming class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.